ଆଉ କେତେବେଳେ ମୁଁ start? Good morning, dear students. I am Amruta and I welcome you back to another video lecture on engineering mechanics. In our previous class, we have discussed about the parallelogram law of forces, and I truly believe that you have gotten a very clear understanding about the topic. And in today's lecture, we are going to talk about some special cases related to that law. So without further ado, let's start our class. ମୁଁ ଭାବୁଛି ବହୁତ ଜଣ ଜଏନ୍ କରିଦେଇଛନ୍ତି. Please raise your hands. Let me see at least 10 raised hands so I can start the class. 10 ଜଣଙ୍କର hands raised ଦରକାର ମୋତେ. Yes, good morning. Good morning, Raghumani. Good morning, Mahendra. Mahendra is always the first. Yes, 8 more. We don't have the whole day. Yeah. Good morning, Tapas. Good morning, Deepa. Yes, 4 more. Yes, yes, yes. Okay, so let them join meanwhile and we'll be beginning our class. Okay, so in the previous lecture, we got to know about the magnitude of the resultant, okay, and we found out it to be r square, no, r is equal to root over of p square plus q square plus 2pq cos theta, where theta is the angle between the two forces, right? Now let us consider that theta is 0, right? Theta 0 indicates that the two forces P and Q both are acting in a single line, okay? If this is our P and this is Q, the angle between P and Q is 0 degree, right? That means both P and Q are collinear. They are acting along a line. In this case, theta becomes 0, and here if we put the value of cos 0, we get r is equal to p square plus q square plus 2p q cos 0 degree. And what is cos 0 degree? 1. So finally we are getting r is equal to p square plus q square plus 2p q's root over, and this is nothing but p plus q's whole square root over and whole square gets cancelled, so we get r as P plus Q. Got my point? Hence R becomes P plus Q. So when the two forces are acting along the same line, we can find out the resultant of them by simply adding them. Okay, so we don't need any vector addition because the direction is same for both the forces, so we can simply add them algebraically, right? First case is over. Let us move on to the second case. Second case रे कौन होची ना, थीटा होची 90 डिग्री. जदि थीटा 90 डिग्री हुए, व्हाट डज दिस मीन? तार अर्थ कौन? जदि गोटे फोर्स एमिति एक्ट करची, सपोज P एक्ट करची ए डायरेक्शन रे, देन P is acting perpendicular to Q, so that this angle becomes 90 degree, right? This is the case, second case, where theta is 90 degree. That means P and Q are perpendicular to each other. So when we consider this case, let's put the value of theta in our expression of R. R is equal to P square plus Q square plus 2PQ cos 90 degree. Theta is 90 degree, so we are using the value of theta here. Okay, and as we all know that cos 90 degree is equal to 0. So the value of cos 90 degree is 0. So this equation reduces to P square plus Q square's root over. Understood? Since cos 90 is 0, this entire term becomes 0 and we are left with R is equal to root over of P square plus Q square here. Okay, बुझीला? जेतेबेले दुईटा फोर्स भितर एंगल 90 डिग्री अच्छी और जेतेबेले से म्यूचुअली परपेंडिकुलर अछंदी, देन हमको रिजल्टेंट रो वैल्यू कौन हबो? P square plus Q square रो root over. So you remember this thing so that when you go for solving problems, you can put these values, okay, without going for the entire derivation of it. If you remember it, you will solve the problems in a short time, right? So जेतेबेले case 3 देखिबा, case 3 रे कौन अछि? जदि theta रो value 180 degree. 180 degree means if this is my P, जदि एटा P हुए, then Q will be acting opposite to P but along the same direction, right? So that theta becomes 180 degree. When theta is 180 degree, P and Q both are acting along the same line but in opposite direction. So what we can do? How we can find out the resultant here? By plugging in the value of theta in the equation of resultant, we'll get R is equal to P square plus Q square plus 2PQ cos 180 degree. And I believe all of you know that cos 180 degree is minus 1. So if we put cos 180 as minus 1, this entire expression reduces to P square plus Q square, minus 2PQ's root over, and ultimately this becomes P minus Q's whole square root over R is equal to P minus Q. If we remove square and root over, we get the expression of R as P minus Q. Got it? I think it's clear to all of you. Okay. Then let's see case 4. In case 4, what we have, suppose P and Q both are equal. Okay. The magnitude of P and Q are same. If P is 100 Newton, Q is 100 Newton. So in such case, what will be the resultant? See, in the expression of resultant, we can put in place of P, we are taking P, and in place of Q, we have replaced Q by P. So we are getting this expression P square plus 2P square cos theta, right? Theta value, theta can take any value, right? So we are getting, if you go with the simplification, we get 2P square into 1 plus cos theta, and this 1 plus cos theta can be replaced by this from this identity. If you remember the trigonometric identity which says that cos square theta is equal to 1 plus cos 2 theta upon 2. So we have used this trigonometric identity and we got the value of R if P and Q both are equal as 2P cos theta by 2. I request all of you to go with this simplification process on your own and show me the result, if you are getting this result or not. And along with this, I am going to give you one homework, right? Suppose in this case, you have P and Q both are equal, right? The magnitude of P and Q are equal, and along with that, if theta is 90 degree, then what will be R? Please find the expression for R when P and Q both are equal and the angle between them is 90 degree, right? If this is clear for all of you, we can move forward and solve some numericals based on this topic. Good morning, Preeti. I think you can catch up with me. If you people have any doubt, you can ask your doubt in the comment section. Okay, so let's go for this problem. The problem says two forces, okay? We have gotten two forces. One is 100 Newton, magnitude of one force is 100 Newton, and another force whose magnitude is 150 Newton. Both are acting at a point. So this is a clear case of concurrent forces, right? Now you are required to find out the resultant of these two forces provided the angle between them is 45 degrees. So we have got two forces, that means if we take this as P and this as Q, and the angle between P and Q is 45 degree. What we have written here, P is 100 Newton, Q is 150 Newton, and theta is 45 Newton. Plug in all this value in the expression of resultant, and solving this, we'll get 100 square plus 150 square, 2 into 100 into 150 cos 45 degrees, and you get this answer. If you want me to solve this for you, I'll go for it. But since it's a very easy problem, I would like all of you to go and solve it on your own. Fine. Okay, let's move on to another problem. Again a very simple problem. The problem says that there are two forces which are acting at angle 180 degrees. Sorry, 120 degrees. So theta is 120 degree here. The bigger force is 40 Newton and the resultant is perpendicular to the smaller one. And we are required to find the smaller force. Since we are given with one of the forces, let's take P as that force and whose magnitude is 40 Newton. Angle between the two forces is 120 degree, that means theta is 120 degree, okay. And the resultant of the two forces is perpendicular to another force, the smaller force, which we have taken as Q, right? So this is P here, okay. Angle between P and Q, if this is Q, then the angle between them is 120 degrees. And what else is given? The resultant is perpendicular to the smaller one. We have taken P as the bigger force and Q as the smaller force. So the resultant is perpendicular to the smaller force. So this angle between R and Q is 90 degree, right? If angle between R and Q is 90 degree, then we get the angle between R and P as 180 minus 90, which is nothing but 30 degree, and which is alpha, right? So that's what is written here. We know that the angle the resultant makes with one of the forces, let's say P, if that is alpha, then tan alpha is equal to Q sin theta upon P plus Q cos theta. Theta here is 120 degree, right? And alpha we have gotten as 30 degree. So after plugging all this value, we'll get the magnitude of Q as 20 Newton. I'm not going to do the calculation for you. Please do it on your own and show me the results. If until now anybody has gotten any doubt, the chat window is open for you. You can ask. You want the notes of this topic, Preeti. Fine. I'll share it in the group. Now I want you to solve these problems along with me and ask your doubts if you have got any. Clear up to now? Shall we move ahead? Yes? Okay. Let's pick up another problem. Okay. So this problem says that find the magnitude of two forces such that if they act at right angles, their resultant is root 10 Newton. But if they act at 60 degrees, their resultant is root 13 Newton. So we have two cases here. Okay. In one case, the resultant is root 10 Newton. And when it is happening? When the two forces are acting at 90 degrees. When theta between the two forces is 90 degree, their resultant is root 10. And in another case, when the angle between the two forces is 60 degree, the resultant of those two forces becomes root 13 Newton. So from this, data, you have to find out the magnitude of both the forces. That means you have to find out P and Q, right? So in case 1, we have given theta is 90 degree, and when theta is 90 degree, we have R as root 10, right? And as we just now we have seen that when theta becomes 90 degree, resultant becomes root over P square plus Q square. Plug in the value of R here. What is R? R is root 10, and which is equal to P square plus Q square root over. Root over gets cancelled. We get P square plus Q square as 10. Yes. Save this finding. Now let's jump on to the second case where theta is 60 degree, okay, and the resultant in that case is root 13. So let's plug in the value of R. 13, root 13 is equal to P, okay, this P square plus Q square already we have gotten as 10. Follow me? 10 plus 2 PQ cos 60. What is the value of cos 60? Value of cos 60? 0.5. Okay. So this becomes 10 minus PQ. Okay. I forgot root over. So ultimately we are getting 13 is equal to 10 minus, sorry, this is plus PQ. So PQ is 13 minus 10, 3. Let's save this data also. We have gotten P square plus Q square as 10 and PQ as 3, right? You people follow me? Preeti, I got late in joining this class. I'm so sorry you joined late. Try to come early. Okay, it's okay. So what we have gotten, P square plus Q square as 10 and PQ as 3. So with this two information in our head, okay, I'm giving you the steps to solve these problems, and I request you to solve it and show it to me. Go with this P plus Q whole square formula and P minus Q's whole square formula, okay, and you will get some expressions of P plus Q's whole square, P minus Q's whole square, okay, and in that expanded form you plug in these values, right? After plugging these values, you will get the value of P and Q, right? So I leave it on to you. I told you the process how to solve it. Please try it at home and show it to me, okay? Let's move ahead and pick up another problem. See, in this problem, we have two forces, okay? Force P having magnitude 50 Newton and force Q having magnitude 100 Newton. Angle between both the forces P and Q is 30 degree. Now you are required to find out the resultant, okay? Resultant's magnitude and direction both, right? Classic case of parallelogram law of forces. This is P, this is Q, okay, and R would be the diagonal, okay, joining the parallelogram. Yes, complete the parallelogram, join the diagonal, name it as R, okay. R is what? Root over of p square plus q square plus 2p q cos theta. I'm not going to do this problem for you at all. Plug in the value of everything, okay, and everything else which is required for solving this problem is given to you. Get the resultant's magnitude and direction. Direction is tan alpha, which is q sin theta upon p plus q cos theta. Right, right. Am I clear? I hope all of you can solve all this problems which is discussed up till now. Okay? This is your task. I'm giving you one question. Okay? Write it down. Try solving it at home and show it to me. The question says that the resultant of two concurrent forces is 1500 Newton and the angle between the forces is 90 degree. The resultant makes an angle of 36 degree with one of the force. Find the magnitude of each force. Clear? Go stepwise. Resultant is 1500 Newton and you are having the angle that the resultant makes with one of the forces is 36 degrees. Okay. From that you can find one of the force and see you have theta as 90 degrees. So this solves your problem. Okay. If you see 90 degree, that means you know that cos 90 degree is 0. Okay. Cos 90 degrees would be 0. So most of your problems are solved. Okay. Plug in the values of 36 in the expression of direction. Okay. And you will solve it. I'm sure you all of you can do it. Right. So let me leave it on to you and let's wind up the class today. This much for now. If you have gotten any doubt, please ask me. Yes, Preeti, Prem. Please raise your hands if you have understood whatever was discussed up to now. I think we are all set. I can leave the class. Thank you guys. Thank you for your patient listening. Bye for now. We'll meet in the next class. कितने टाइम रहला 30 minutes